project manager on the home modernization team. I run the Experience Clean Heat initiative, which you'll hear more about shortly from Courtney Moriarta, the director of the home modernization team, who will provide some of the context for how this initiative started. I am very happy that we have been able to partner with DEC to promote the Five Rivers Environmental Education Center as an Experience Clean Heat site and run trainings like this one. We are joined today by DEC staff, and we will hear some introductory words from Brendan Woodruff, the Director of Sustainability at DEC. The bulk of our presentation today will be given by Paul Stathis, a heat pump expert with TRC Companies who serves as a field ambassador for Experience Clean Heat. We will walk through the different heat pumps installed across DEC facilities, along with useful operation and maintenance tips. I'd like to give a quick shout out to Diane Bertog, the Energy Bureau Director at New York State Parks, who is also listening in on this call. Hopefully, we'll be able to work through a partnership with Parks in the near future to continue this kind of collaboration across state agencies. Next slide, please. And just some webinar procedures. Attendees will all be muted upon entry. If you want to submit any questions or comments, you can submit them at any time through the Slido Q&A feature. Just click the three dots at the bottom right-hand corner in the screen and select the Slido option to open the feature. If you have any issues, please feel free to reach out. And with that, I'll turn it over to Courtney to get us started.
Great, thanks, Tamar. And we're really excited to hold this joint brown bag lunch session with our partners at DEC. This is a pretty exciting initiative and really happy to see this cross-agency coordination happening and hope that we can continue to do more in the future. So I wanted to so first of all, I should introduce myself for my DEC colleagues. I'm Courtney Moriarta. I am the director of our home modernization team here at NYSERDA. And what that means is what my team focuses on is anything that we do related to 1 to 4 unit homes across the state. And so we run all of the programs that provide improvements and incentives to make energy efficiency and clean energy improvements to homes across the state. We work directly with homeowners on a lot of initiatives to provide home energy assessments, weatherization, and transformation to clean energy options for heating and hot water statewide. And then we also have this initiative that we kind of internally refer to as our supply chain initiative. And the real point of that was to look at ways that we can intervene in the market and really be influential in encouraging the supply chain overall to adopt and embrace these clean energy technologies that we're trying to pursue statewide. So really outside of the incentive programs, the supply chain work that we do really focuses on the market at large and trying to figure out ways that we can be as influential as possible with the kind of limited amount of money that we have to spend on those endeavors. So what this slide is showing is kind of a background on how we got to this point and how we selected this Experience Clean Heat initiative as one of the areas that we wanted to invest in. And it really started with a series of roundtables and interviews that we held with actors across the supply chain. We did a series of these interventions to kind of gather market insights from contractors, distributors, and manufacturers of heat pumps. And our aim was really to understand how we can, what are the things that NYSERDA can do to sort of intervene in the market the way that it exists today, and sort of transition the HVAC market, which, as you know, is probably about a 100-year-old industry, and start to turn it more towards voluntarily adopting heat pumps and accelerating our deployment of heat pumps statewide in the residential sector. So part of the outcome of that process was we really took a good solid look at what the market overall looks like. We were able to kind of map out the relationships across the different market actors in the supply chain and get a better understanding of like what drives them, how do they make money, how do they interact with each other, and what are the pain points that they experience when they're trying to transition to maybe bring in a new service line or start to support a new technology like heat pumps. And then after going through that process, we were able to sort of create a short list of areas where we felt that there were places that there was an opportunity that NYSERDA could actually make an impact on the market by intervening in some way. And you can see on the far end of the slide here over on the right, some of the key areas that we landed on include the heat pump planner, which is available on our website. And that's a tool that we created for consumers to use jointly with contractors to help them understand, basically take a virtual test drive of a heat pump before they make a decision to purchase one for their home. We have our Clean Heat Connect network, which is a network of partnerships with distributors and manufacturers statewide, where we provide tools and resources to them that they kind of tell us what are the things that would be most useful to them. And then we build those tools and resources and make them available. And then they, in turn, take those tools and resources and share them very broadly to the market at large with the contractor networks that they serve. So it's a really efficient way for NYSERDA to get different kinds of tools and resources in the hands of contractors, whether they participate in programs or not. Experience Clean Heat is what we're here to talk about today. And this is kind of a fun initiative that's really kind of a marketing, general awareness type of initiative, but we're leveraging partnerships with local businesses, municipalities, and also agencies like DEC to identify sites that have already put heat pumps in, where people go, where the general consuming public goes and spends time. And we're kind of creating awareness around those sites. So when people are in there spending time, they know that they're actually experiencing a location that has a heat pump, and gives them the ability then to sort of anchor their thinking on that. So when they are thinking about a heating system for their home in the future, they kind of have some familiarity with a heat pump, and they can kind of tie it back to that experience that they had while they were at one of these sites. So go ahead to the next slide, please. So these were some of the goals that we were trying to take on with the Experience Clean Heat initiative. So really, we were looking for a way to really get into the hearts and minds of the consuming public and the market at large, and get them thinking about heat pumps in a different way. So we were looking to really use it as an educational opportunity by kind of putting people right into the experience of being in a place that has a heat pump, and understanding that it heats and cools efficiently and can make a place comfortable, depending of any size or shape, really. We really were seeking to normalize heat pumps as a technology. We know that there are a lot of myths and misconceptions out there about heat pumps, and we're seeking to overcome those through the educational opportunities that we have at these sites. And then it also serves as a tool for us to also get the word out about any programs that might be available either through NYSERDA or through the utilities, to get incentives and to get more information about heat pumps and to connect with contractors who can install them. So it's also a market transformation and demand inducing initiative as well. So it sort of crosses over between partnerships with business and marketing and general awareness, and then feeding consumers over into working directly with contractors and programs. Next slide, please. So I kind of explained what's on this slide, the words that are on this slide. This picture is one of our sites. This is the Artisanal Brew Works in Saratoga Springs, New York. And this was one of our very first sites. They're one of our best partners. And you can see what we're doing here. You can scan the QR code to go directly to our website and get more information about the sites overall across the state. But we kind of put up signage. We work with the staff on the site, and we try to encourage them to be available to talk to their customers about the heat pumps if they have questions. And then there's a series of events that we sponsor, and we work with our site partners to put on to draw more attention to the heat pumps. And then we're looking to use those experiences then to drive more social media awareness and bring more people to these sites. And we'll go to the next slide. And the next slide is going to show us some of the impact that we've had to date. So in just a little over a year or so of being in the market, we've managed to recruit 46 sites statewide. We've measured over 65 million impressions on social media. And we've also helped our partner sites to host 37 events, with 2 of those being statewide across multiple sites. And you'll see if you go to our website and if you stay tuned on our social media channels, we're hosting more events over the coming months statewide. So stay tuned on that. And we'll go to the next slide. And this slide is just going to show the map of where all the sites that we currently have enrolled in the initiative, where they're located. Again, you can scan the QR code and go directly to our website and kind of explore this map and see what all these sites are. They run a wide gamut of different kinds of businesses. There's also libraries and town halls, and there's, I mentioned the brew works. There's also retail shops. So it's a pretty wide variety of locations and different kinds of experiences that people can have. And you can see where the Five Rivers Environmental Education Center is located. And with that, I'm going to hand it over to Brendan.
Yeah, thank you. Thanks, Courtney, and Tamar and Paul. I'm very proud that Five Rivers is in the program. As most of our folks know, Five Rivers has a lot of environmental initiatives going on at it. I also need to ask you where you got that heat pump costume. We might have to get one of those for ourselves. That's pretty incredible. But thanks, everybody. My name is Brendan Woodruff. I'm the Director of Sustainability here at DEC. And we have been working on heat pump technology for quite a while now. It's replacing fossil fuel use at our facilities. It's keeping our staff and our visitors more comfortable. And it's helping us heat and cool spaces that we weren't able to before as the technology continues to improve. I've also become somewhat of a heat pump evangelist myself, having installed one in my house this fall. It has worked fantastic through this latest cold snap. It's rated to 100% efficiency down to -22. I didn't think that would get challenged, especially right away. But we've had no issues. It has run incredibly well. It's been efficient. The house has been comfortable. I can't say enough great things about where the technology is now. So a couple benefits for DEC of why we're doing this and why we're presenting on this today. The first is it improves the user experience. So this technology makes our buildings more comfortable, as Courtney was talking about. It can reduce noise at our facilities, and it can instill pride in our residents. People look to DEC to lead by example. That's one of the reasons we work so hard to do as much with our sustainability program as we can. And when we adopt heat pumps, when we talk to people about our heat pumps, it lets them show that we're leading by example. It makes them, much like the Experience Clean Heat program, think about them for their own houses and homes as well. It helps us lead by example, and it also helps us reduce emissions as well, which is a goal of ours, it's a goal of the governor's, and it helps us on that path. Next slide. So there are some policy requirements that are supporting our heat pump development. I just wanted to lay this out here as well. Section 7.1 of the climate law, it's a directive that we have to directly reduce our operational greenhouse gas emissions within the agency. Executive Order 22, which was signed by Governor Hochul back in September of 2022. That includes requirements to reduce greenhouse gas emissions. And as part of that, we've been prioritizing the installation of heat pumps at our facilities. If we need to replace our HVAC systems, in a lot of instances, this is leading to us replacing fuel oil or propane with heat pumps, which can also cut costs for us, especially on the fuel oil stage. Commissioner's Policy 75, which for us requires that DEC be carbon neutral in our operations by 2050. Heat pump adoption and building electrification is a huge part of that. When we look at our overall emissions profile, about 1/3 of them are coming from our building heating systems. And so adopting heat pumps is how we can get to that target. And then within our own sustainability plan, that requires us to prioritize the electrification of our heating and cooling systems. So just wanted to give you kind of the policy background here as to another reason why we're doing this at all of our facilities. Next slide. And so with that, I'm going to hand it back over. We'll talk a little bit about Five Rivers and then get into some more heat pump info. Thanks.
All righty. Thanks, Brendan. So my name is Paul Stathis. I work at TRC supporting the Experience Clean Heat program. And you may also recognize me as the guy in the heat pump costume from earlier in the slideshow. And today I'm going to talk to you a little bit about heat pumps in general, how DEC uses them, and then how to operate and maintain them to get the best performance out of your system. So the reason that I'm here today is because Five Rivers is one of our Experience Clean Heat sites. Like Courtney mentioned earlier, this means that they have signage installed to point out their heat pumps, and NYSERDA runs social media and events to promote the site as a place where New York residents can experience a heat pump firsthand. And it also lets us run trainings like this one. So the ground source heat pumps are one of Five Rivers' sustainability features that makes their visitor center LEED Platinum certified. And those heat pumps meet all of the building's heating and air conditioning needs. And combined with their rooftop solar and some other energy efficiency features, the ground source heat pumps make Five Rivers a great example of green building practices. So the heat pumps themselves are super efficient electric heating and cooling. For each unit of electricity that they use, these heat pumps can put out 3 to 6 times that much heat. So next slide, please. Okay, and then moving on to heat pumps in general. What are they and how do they work? Next slide, please. Okay, so generally speaking, a heat pump is a machine that uses a fluid called a refrigerant to move heat from one place to another. So an air conditioner is a heat pump, a refrigerator is a heat pump. And during the summer, the systems that we're talking about today work exactly like an air conditioner does. They pump heat from the building to the outside. But the key difference is that during the winter, these heat pumps can reverse the direction of refrigerant flow and pump heat from the outside to inside of the building. Next slide, please. Okay, and that probably sounds pretty odd to get heat from the cold outdoor air. But even when it's extremely cold out, like it has been the last couple weeks, air source heat pumps can still extract that air, concentrate it, and bring it inside. So the heat pumps that we use in New York State, the air source heat pumps are called cold climate because they do perform very well, even down well into negative temperatures. And all heat pumps are taking advantage of the fact that it takes less energy to move heat than it takes to create it. So that fact lets heat pumps actually have more than 100% efficiency. You get more heat out of them than the electricity that you put in. Next slide, please. So the other type of heat pump that we're going to talk about today is called a ground source heat pump. So generally speaking, these work the same way as the air source type, except as the name implies, the outdoor part of ground source heat pumps is underground. So during the summer, you'll be able to extract heat from the building and reject it underground. And then during the winter, a ground source system will be able to collect heat from underground and bring it into the building. And next slide, please. Okay, so why bother to go underground for all that heat if it's possible to get it from the air? Over the course of the year, the sun heats up the ground and the ground stores that heat. So once you get deep enough, usually about 6 feet or so, you're away from the seasonal swings in air temperature, and the ground is a very constant temperature year round. For New York State, that's usually somewhere in the 50 to 55 degree range. So on an exceptionally cold day in the winter, a ground source heat pump has access to that warmer heat source, and that just gives it an efficiency boost over an air source system in that circumstance. And just like air source, ground source systems are also taking advantage of the fact that it just takes less energy to move heat than it takes to create it. Next slide. So then ground source heat pumps are generally divided up by the type of heat exchanger that they have underground and also the way that they distribute heat inside of the building. Next slide, please. So the first one of these options is called a closed horizontal ground loop. And this is a sealed system of pipes filled with water and a non-toxic antifreeze that runs between an outdoor trench and the heat pump inside of the building. So right, that wide heat exchanger underground just gives the heat pump lots of surface area to transfer heat between the building and the ground. Next slide, please. So at DEC, the Godfrey Point Sign Shop and Mount Loretto Maintenance Center use a horizontal ground loop. So the picture in the center is just a general example of how this setup looks before it's buried. You can see the heat exchanger is kind of this long, slinky shape that's extended about 6 feet underground. And then the indoor side of the system, you can see where the pipes from the ground loops run into the actual heat pumps themselves. And next slide, please. All right, so there are also vertical ground loops for ground source heat pumps. And this is a very similar setup to the horizontal. It's a sealed off system of pipes filled with water and antifreeze. Except for a vertical system, you're going deep underground, usually about 500 feet or so. And that's where you're getting that extra surface area. So you save a little bit of horizontal space that way. Next slide, please. Okay, and this is the type of ground loop that Five Rivers uses. There's also vertical systems at Stony Hill Farm and at the New Paltz office. And that's where this photo is from. So at New Paltz, this is a larger system, but the general principle is the same. You're running that brine, that water antifreeze mix, out between the ground and the heat pump. And then during the winter, you're extracting heat from that brine. And during the summer, you are rejecting heat back into the brine and back into the ground. Next slide, please. Okay, so another option for ground loop is called an open water loop. So this one's a little bit more situational, but if you have access to a source of water, like a pond, river, lake, or even a water well, you can just pump that water from the source to the heat pump inside of the building. And then once you extract heat from it, you can just return the plain water to the source. Next slide, please. And the manager's house at the Van Hornsville Fish Hatchery actually uses this type of system. So the photo shows the indoor side of the system. Again, the heat pump is just a fairly nondescript gray box, but they did also send over a diagram of how the system works, just to give us an idea. So the blue loop on the diagram is their well. So they can take some overflow from the well, run it to a heat exchanger where it connects with a secondary loop. That's the green loop there. The green loop is also full of water, but that would be filled with like purified or distilled water, just to make sure that what's getting into the heat pump itself doesn't cause any corrosion or unwanted mineral buildup. So then the heat pump is able to collect heat from that secondary loop and concentrate it and send it into that third red loop, which connects to the house's radiant heating system. And next slide, please. Okay, so then moving on to the type of indoor distribution. This is a picture of the ducted system at Five Rivers. So this looks an awful lot like a central AC unit air handler. And the idea is exactly the same, that you have that air handler connected to ductwork that moves the heated or cooled air around the space. Next slide, please. And so because those air handlers and ductwork are hidden away, it would be easy to walk through the visitor center and not notice the heat pumps at all. And so this is why the Experience Clean Heat program wants to draw attention to these systems and further the green building information that the visitor center already has. Next slide, please. So then the other type of heating distribution is hydronic, using hot water to move heat around the building. And this is what the Mount Loretto Maintenance Center uses. So you can see in the lower picture, you have the heat pump itself, that gray box. And then to get the heat around the building, it's connected to the manifold in the upper picture. So then those white pipes run under the concrete slab and distribute heat all around the building. Next slide, please. So then moving on to air source heat pumps. Air source systems are generally divided by what type of indoor unit you have. So next slide, please. So similar to ground source, air source heat pumps can have ducted distribution. This is an example of the air source heat pump that the Boonville Maintenance Center has. I wanted to highlight this one because it's a little different from the air handler that Five Rivers uses. So this is what's called an A-coil. So the indoor part of the heat pump is sitting on top of a furnace. So the heat pump in this case is just the heat exchanger, and it's relying on the furnace's blower motor to move air over that heat exchanger and around the building. Next slide, please. So here we have a ductless or a mini split heat pump. This photo comes from the Sherburne sub-office. And as the name implies, ductless heat pumps just do not use ducts to distribute the forced air around the building. So instead, everything that would be packaged into an air handler, that heat exchanger, blower motor, condensate management, filters, is all packaged inside of one of these consoles. And usually they sit up high on a wall. Next slide, please. Then another option is called a multi-split air source heat pump. And all that means is that you have more than one indoor unit attached to an outdoor unit. These two photos are not from DEC sites, but I just wanted to highlight a few of the other options for what the heat pump indoor units can look like. So you have a ceiling mounted unit on the left and a low wall mounted unit on the right. So these can be good options if you want something a little more inconspicuous, or if, like in the photos, you have a lot of windows on the walls that would prevent you from installing the more typical high wall-mounted unit. Next slide, please. Okay, so then I'm going to move on to some operations and maintenance tips for your heat pump. Next slide, please. Okay, so when it comes to running your heat pump, the best thing you can do with your thermostat is to set it and forget it. Heat pumps perform at their best and you find a comfortable temperature and you just let the heat pump run. If you do have let's say an office that you want to use a nightly setback, you want to turn the heat down overnight, that is still an option, but you just want to make sure that you are bringing the temperature back up more slowly. So if you use a setback, I would say just raise the temperature by 3 degrees, let the heat pump get up to temperature, raise it by 3 degrees, let the heat pump get up to temperature. That's just going to let the system run more efficiently than if you try to make up, let's say a 10-degree setback all at once. Then even if you have a backup system, you want to rely on the heat pump as your primary heat source. And this is because heat pumps are very, very efficient. But to get that efficiency, you need to run them. So you want to make sure that you have your thermostat set so the heat pump is going to be primary. Then for temperature settings, you want to use the heat setting in the winter and the cool setting in the summer. Some models have an auto temperature mode, but I recommend that you do not use that because in mild weather, the automatic mode will switch the heat pump rapidly back and forth between heating and cooling when you might be just as comfortable with neither running. And then for fan settings, you want to start with your heat pump on automatic fan mode. And then if you find that you're not getting the heating or cooling everywhere that you want it to be, you can experiment with the fan settings a little bit, and you just want to leave the fan at the lowest setting that is going to meet your needs. Next slide, please. Okay, so then maintenance tips. So this is something that you're going to hear me say over and over again, but one of the most important things that you can do for your heat pump is to maintain enough airflow through it. So one of the best ways to do that is to keep on top of your filter maintenance. So if you have a ductless system, those usually have washable filters. So most manufacturers recommend cleaning those about once a month. And you can either vacuum them off or rinse and dry them. And then for ducted systems, those generally have disposable filters similar to central air or a furnace. So that could be either in the air handler itself or in the return grill. And generally, you want to replace those filters about once every 90 days. Next slide. So then for the condensate drainage system, this is something that you'll want to clean out once per year. You can use either a dilute bleach solution or they have purpose-made cleaners for this. And basically, you'll want to get into the condensate pump that is circled in yellow on the bottom there, and also cleaning out the drain pan and any traps and vents. So I recommend doing this in the spring before you start running air conditioning. And especially if you have a condensate line that drains to the outdoors, you want to make sure that that's going to run clear. Because over the winter, you can get a little bit of debris in the outdoor side of that. You can get some, bugs or dirt in there. And then when you, if it's clogged, when you start to run the air conditioning, the water that would normally drain out of there can back up into the building. So always good to catch that before you get some surprise water on the first warm day in spring. Next slide, please. Okay, and then for a visual inspection, you just want to make sure that you get eyes on your system at least once every 90 days. So this will help you get a sense of what's normal. And you should also be looking out for any parts that look dirty or damaged, any excessive or new noises, any leaks. And then you can also check if the control settings have been changed at all, and if you have any error messages. Then there are some things that you would leave for professional maintenance. Generally, the manufacturers recommend having this done once per year or once every other year. And in general, you always want to keep a log of any maintenance that you do or that you have done. That just helps you keep on schedule and helps prevent misunderstandings, especially if you have multiple people working on the same unit. Next slide, please. So then on the indoor side of the system, if you have forced air, you want to make sure that there's no airflow blockages indoors. So you want to keep furniture and carpets off of duct registers. And if you have a ductless system, you want to keep furniture away from those. You just don't want to block the airflow coming out of the heat pump. Then if you do not have distribution in every room, so let's say you have one ductless unit, you can keep doors open to help cycle air, the conditioned air through the entire building. And then on the other side of that, if you have something like a storage room that you don't really care if it's conditioned or not, you can just leave that door shut and save some energy. Then for seasonal maintenance, you want to check the indoor and outdoor equipment at least once per season. If you have a ground source heat pump, there is not very much to check. Everything is going to be buried and inaccessible, but the air source heat pumps do have outdoor units that look like AC condensers. And generally what you're going to be looking for is any obvious signs of damage, looking for signs of mold, like ice buildup, water dripping from the indoor unit. Yeah, just anything clearly out of the ordinary. And if you do find that an indicator light is on or you're getting an error message when you're doing this kind of general check over, always try to clean or replace the filter first before you call in an HVAC tech. A lot of times, if a heat pump recognizes that it is not getting enough airflow, it will give you an error code. And next slide. All right, and then, so because the refrigerant circuit is really the heart of the heat pump, I wanted to talk a little bit about refrigerant leaks. They're pretty rare overall, but they are slightly more common if you have a system that required making a refrigerant line connection in the field as opposed to in a factory. Right, just doing that work in a controlled condition in the factory makes it a little bit more reliable. So refrigerant leaks are usually very, very slow. They're so slow that you wouldn't be able to see or hear them happening. So you kind of have to keep an eye out for the signs and symptoms rather than noticing the leak directly. So the first one to look out for is poor heating and cooling performance. This usually comes on gradually because the leaks are slow. But if you're noticing that over the course of weeks or months, the heat pump is just not putting out as much heating or cooling as you'd expect, that can be a bit of a red flag for you. At the same time, you would see higher energy use. So the heat pump working harder to make up for less refrigerant in the system while still not keeping up performance. And then if you lose enough refrigerant, you will start to see some ice on the cold side of the system. So inside in the summer, outside in the winter. And that's what this photo is here. So you can see two air source heat pumps running side by side in the winter. The one on the left is looking fine. The one on the right is covered in ice. So if you saw something like this, the first thing that you would do is look up and make sure that there's no obvious external sources of ice or water making this happen. And then if not, that doesn't necessarily mean that it's a refrigerant leak, but that would be a sign to probably call out a tech to have them diagnose this. The air source heat pumps do also have a defrost cycle for their outdoor units. Because they're out in the cold winter air, we do expect a little bit of ice to accumulate on them, but the defrost cycle should be able to take care of that under normal conditions. So it's possible that this icy heat pump is having an issue with its defrost instead of a refrigerant issue. And then last thought on refrigerant leaks. So this isn't always visible, but the compressor has some oil in it for lubrication. And sometimes if there's a leak, a little bit of that oil will get forced out through the leak, and you'll be able to see some residue at the refrigerant line connection. So that is another red flag that you might have a slow leak. And next slide, please. Okay, then for air source heat pumps, you do also have to maintain airflow through the outdoor unit. So all of the manufacturers are going to have slightly different guidance for this. So you can always refer back to the manual and see how much space you need around the outdoor unit. This top photo looks like somebody wanted to get this heat pump tucked away, just somewhere a little bit less visible. And they ended up installing some fences a little bit too close to it. And this is going to reduce the amount of air that can get through the heat exchanger, and it's going to drop the efficiency. And then generally speaking, you do want to keep leaves, snow, any other kind of debris out of the outdoor unit. And during your annual maintenance, you can clean out the outdoor unit. You just wash the heat exchanger with some soapy water and hose. One word of caution on that, you do want to be very, very careful not to bend the fins on the heat exchanger. So yeah, just a gentle hose setting. Yeah, never use a pressure washer, because if you bend those fins over, you'll choke off the airflow like as much or more than if the heat pump was dirty. Then the lower picture is one heat pump installed right over another. So as I mentioned earlier, in the winter, the air source heat pumps are going to have a defrost cycle. So when that top heat pump runs its defrost, it is going to drip water onto the lower heat pump, where it's going to freeze and ice it up. So on the installation side, if you can keep from installing heat pumps like this, I recommend not doing it. But if you already have a setup like this, or let's say the heat pump is under a roof where you notice it just gets dripped on a lot in the winter, you can just put a little shield over the top of it. Yeah, and generally speaking, you just want to keep these outdoor units free of obstructions year round. Next slide, please. And then for hydronic systems, where you don't have any of this forced air to think about, the main thing that you're going to keep an eye on is the system pressure. So generally, when the system is cold, that's going to be about 12 psi. When things are up and running, usually in the 20s. And then 30 psi is where you start getting fail safes coming into place. Like you'll have a pressure release valve let go and things like that. So that's a sign of something being off. Hydronic systems also have air tanks. So if you're noticing that the heat is uneven or you're getting some unexpected temperature swings, the air tank is a good thing to check first. So it's a tank attached to the hydronic system that has basically a balloon full of air in it. That helps even out the pressure. So if you knock on this tank, it should sound light and hollow. You should be able to tell that it's full of air. If you get a heavy clunk, that means that the tank is full of water and it has failed. Some systems will have an in-feed water regulator. So this basically will automatically add water to the system if it detects that it's low. I recommend leaving these off because if you have a slow leak in a radiant system, you really want to catch that early. And if it leaks and you lose some pressure and you lose some performance, you can catch it early. But if you have the in-feed water regulator on, it'll just keep topping the system off while you're losing water somewhere else. Some radiant systems do also have filters to catch dirt and debris. So usually you will empty those out once per year, generally in the fall before you start heating. And that's just a small Y-shaped section of pipe that you can clean out after you isolate it. And for the more day-to-day visual checks, really what you're looking for is leaks and corrosion. So this is something that if you catch a small leak or a rusty spot, that's pretty easily repairable. But if it goes a long time and a pipe lets go, then that becomes a much, much bigger problem. Next slide, please. All right. So then that was all I had. If you're interested in learning a little bit more about Experience Clean Heat, you can use the QR code or go to the website or send us an email. Yeah, and then yeah, we can take a look at the Q&A for questions.
All right, awesome. Paul, I can go ahead and ask you some of those Q&A that have come in.
Yeah,
That
go for
works
it.
for you. Okay. Are ground source heat pumps feasible in cities like New York City, where there's already a lot of underground infrastructure?
Yes. Yeah, so it does take a little more planning to, figure out where you're going to put that ground heat exchanger, but it is totally viable. Actually, St. Patrick's Cathedral in the city uses a ground source system.
Awesome. Are ducted heat pumps feasible for large multifamily apartment buildings?
Yes. So yeah, you can use multiple air handlers in a large building. Usually the way that I see this is like one air handler per zone or per dwelling unit.
Mm-hmm. Awesome. And if an existing residence has central air or steam pipes, can the existing infrastructure be adapted for heat pumps?
Yeah. So central air, yeah, it is really common to reuse ductwork from central AC systems. If you are planning on doing that, I would say just check, make sure you're able to get enough volume of air through them, right? Because it gets colder in the winter, then it gets hot in the summer. You just need to move more heat through that ductwork in the winter. So just make sure that you have a little extra capacity in the ductwork. Steam pipes are a little more difficult. I'm not sure if you could retrofit a heat pump onto a steam system because where heat pumps really shine is generating kind of lower grade heat very efficiently. So typically, if you have a boiler, you'll end up using like a lower distribution temperature. Yeah, more like a hydronic system.
Thanks. For ground source heat pumps, how is maintenance done for the underground pipes? If pipes break or need to be replaced, does the whole system need to be dug?
So as far as general maintenance goes, there is not really anything to do on a regular basis. And then if you do have a leak, it it does depend where the leak is and yeah, how the ground heat exchanger is set up. So a lot of times, if you have a leak that you don't know where it is, or yeah, it's just hard to chase, you can seal and cap off either the whole system and dig new, or if you can chase the leak, you can isolate that part of the system and yeah, just seal that off and replace only part of it.
Awesome. All right. I'll see if anything else is coming in. Courtney, do you want to take this question live about if there's any data about how heat pumps have performed in more extreme conditions?
Yeah, sure. And it's actually a really good question to ask right now. So we actually are helping to sponsor a study that actually Paul's company, TRC Companies, is carrying out for us, and we're calling it our polar vortex study. But the idea was for us to actually monitor the performance of heat pumps that are installed in homes in New York State during the cold winter. And we had planned on doing this study last year, and we weren't able to quite get our act together and get it off the ground in time for the winter last year. So it got pushed to this year, which turns out to be sort of a lucky accident because it's been so cold this year, and it really wasn't that cold last year. So early returns from that study are that most of the sites are holding steady and the heat pumps are doing a good job. So we're pretty excited to know that even in these like 15 below mornings that we've been seeing, that the heat pumps seem to be doing their jobs properly. So we're hoping to have more information on that we'll be able to present we have a conference coming up at the end of May in Saratoga Springs, the Clean Energy for Homes Conference. And we're hoping to show some preliminary results of that study at that conference. So maybe stay tuned on that one too.
Yeah, and I do actually also work on that study. One of our houses is way up in Watertown, and they had temperatures down around -20, -25, and yeah, their air source heat pump ran just fine through all of that. Okay, let's see if we have any other questions coming through.
Yes. Any suggestions on keeping electric bills low while using heat pumps? This person had an electric bill of $400 last month versus 80 to 100, even when the temperature was set at 55 degrees in the house.
Oh man. Yeah, so it's a little hard to know without knowing details of the house. If you're getting unusually high bills, I would say you can check for performance issues. Something like that. Refrigerant leak can cause higher bills. The colder weather will cause higher bills. And also just generally having a less insulated house will take more to heat it. There might also be something on the distribution side. So I mentioned that heat pumps are moving a larger volume of warm air. So if you have leaky ducts or uninsulated ducts, that might also be contributing.
I would add
hard to know without. Sorry.
I was just going to add that the other issue that we sometimes see with these installations is that the connections on the refrigerant lines are not connected the way they're supposed to, and so you can get those refrigerant leaks that Paul talked about earlier, and that could also potentially contribute to performance issues with your heat pump. So I would say if you're getting bills like that and that was unexpected, and you do need to bear in mind any offset of what you were paying for fossil fuel previously, in addition to your previous electric bill in that calculus. But if you are getting surprisingly high bills, get back with your contractor and ask them to come out and take a look and troubleshoot your equipment, because it shouldn't be giving you that much of a difference in price if that was really a one-to-one comparison between what you were paying for heat before.
Thank you. We did get an interesting question in about how we measure the impact of this program on consumer attitudes and behaviors, and what are the results. I'd love to know the answer to that question too. It's something we're trying to work on right now, and we collect a lot of data with this program, to try and measure that. But because it is about customer attitudes, there's a lot of different things that we're measuring to try and get at that full picture.
So it's a work in progress.
Yes, work in progress. But some of that is, just seeing how many times someone might engage with our posts on social media, the quality of interactions we get at events that we run, and then also trying to we would like to survey the sites and the site staff to see if they've noticed impact with the signs and with customers going through the site. But yeah.
Yeah, I would also note that NYSERDA, so this is one of many general awareness campaigns that NYSERDA operates, and trying to get the word out and educate people on heat pumps and get them more familiar and to sort of move the needle on hearts and minds. We also run a annual survey, like a market survey, to understand what consumer attitudes are towards various clean energy technologies, and heat pumps is one of them. So like overall, we're monitoring general awareness and acceptance of these technologies through that survey in a longitudinal way. So we're able to track how things change year over year. And, that's really a better way for us to understand the full impact of all of the initiatives that NYSERDA is doing out there.
Awesome. Thank you. There's one last question that I think we have time for related to the high energy bill. This person also had a 300% bill increase this month compared to last. They thought they saw another study saying that turning heat pumps on and off, like turning it off in the living room overnight, could work well for saving money. Should they leave it on instead?
Yes. Yeah, I would say to leave it on for yeah, if you have any short periods of time like that, I would leave the heat pump on. Usually I say for anything less than going away for the weekend, you just leave the heat pump, let it do its thing, because these systems can actually ramp up and down. So if you give it a big temperature swing to make up, the heat pump will actually run much harder to do that.
And I'll also note, I've seen some of those studies too, and most of what I've seen, they're fairly small in scale. And I think at least one that I saw was done in fairly mild temperatures. So that's a very different kind of situation from the very cold weather that we've been having. It gives it, and if your home isn't insulated very well, if the rest of the house really cools down, it takes a very long time for the whole home to recover back to the temperatures that are comfortable for you. So it all kind of depends on what the actual temperature swings are that you're seeing outdoors, and also how well insulated and sealed the envelope of your home is, how well it's actually keeping the heat in. So I think to do that turn off, turn on thing and see better savings, you really need a better insulated home, and you also need it to be happening in probably milder temperatures. But that's an area of study I think that we haven't quite settled yet.
Awesome. We are at time, so I do want to just note that this session is being recorded. We're happy to share it with whoever wants it, and we can also share a final FAQ document with that, as well as the slides. Thank you.
Well, thanks everybody.
Thanks, everyone.
Appreciate you taking your lunch hour with us. Bye-bye.